We're jumping into chapter 4, which is quadratic functions and relations. We're going to start with 4.1, which is graphing quadratic functions. As this is a new chapter, we're going to have new vocabulary, so go ahead and pause the video and take a second to write down these words. Let's first go over some basics. This right here is an example of what a quadratic function is going to look like. We know this because the greatest exponent is a 2. So in order to be a quadratic function, the greatest exponent has to be 2. These functions can have a quadratic term, a linear term, and a constant term. So if we have this term right here is called our quadratic term. This is called our linear term. And this is our constant. In this equation, in this function, our a, b, and c are just numbers. They can be any number, and our x and our f of x are our variables. Also, the graph of this function is what's called a parabola. You've probably heard this before. Parabola is what the graph is. Yep. So let's go ahead and take a look at the basic parent function. So if we have f of x is equal to x squared, this is called the parent function. Alright, so we're going to graph this function, and it helps to make a table first. So anytime that you see something that isn't linear, we've been working with linear functions, but see something that isn't linear, it's helpful to make a table first. I like to make tables that look like this because they show the progression of what we're actually doing, how we're plugging things in. So we can go ahead and start by just picking some x values. I'm going to start with -2. So if we take -2, and that's our x, so we're taking -2 and plugging it in for x, correct? So we're going to end up getting -2 squared, which gives us 4. And then I want to write this as an ordered pair. The last column is saying my x, comma f of x, where f of x is just another way to say y. We can write it as the ordered pair -2, comma 4. Cool. Now we're going to continue to do this for some more points because we at least need 2 points, probably more, right? So -1, -1 in parentheses squared. -1 times -1 is a positive 1. So we get the point -1, comma 1. All right. Then let's look and let's do 0. 0 squared gives us 0. So the point is 0, comma 0. Let's do another one. 1 squared. 1 squared gives us 1. We're left with 1, 1. And we'll do 2. 2 squared gives us 4. We get 2, comma 4. I want you to look at this table and see if you notice anything. Is there any patterns that you notice? Take a second and see if there's some patterns you notice. So I notice that in the f of x column, we have a pattern. It goes 4, 1, 0, 1, 4. And we'll notice when we graph this that this is because there's an axis of symmetry where we're going to have 2 congruent halves of our parabola. Okay, so let's use our ordered pairs to go ahead and graph this. So our first was -2, 4. So if this is our x-axis and this is our y-axis, we need to go left 2 because it's negative, and up 4. 1, 2, 3, 4. So right here is where I'm going to put a dot. Okay, and then we have the next point is -1, 1. So that's going to be right here. And then we have 0, 0. 1, 1. And 2, 4. So if you notice, we have the shape of a parabola. So it's kind of like a U. When we draw our line through here, we want to make sure that we're not just drawing straight lines between each of the points. We want to make sure that it's a little bit curved. So we're going to have something like this, and beautiful, so good looking right now. Okay, so it's going to look something like this, where it's not flat at the bottom, it's not flat right here, it's supposed to be a little curved. Okay? So just like we noticed in the table that our f of x values had a pattern, it shows up here in the graph as well. So it's because we have this symmetric U that we've just drawn, a parabola, right? And we have an axis of symmetry, which, if you remember back to geometry, there's typically an axis of symmetry. And this right here is a reflection of two halves of the parabola. So right here, which happens to be the y-axis, is our axis of symmetry. Because if you were to take this side, fold it over, it should look exactly like this side, which mine doesn't exactly look like that, but it's okay. So a parabola is just a reflection over your axis of symmetry. And if you notice, the axis of symmetry only touches the parabola at one point. And this will always, 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 always be the vertex of our parabola. The axis of symmetry always goes through the vertex of the parabola. And right there is the vertex. So this is the basic or parent function for all quadratic functions. If we have f of x equals x squared, this is our starting point for what all parabolas are going to look like. From here, if we change this equation at all, it's only going to shift our parabola up, down, left, or right. I want you to pause the video and write this down. Now, when we graph quadratics, we can always make a table of values like we did previously, but it's also helpful to have some formulas that we can find the axis of symmetry or x-coordinates that we can graph maybe a different way than just finding the table of values. So let's do an example. We have f of x equals x squared plus 4x minus 3. And in this example, I want to go ahead and find all these pieces. I want to find what the y-intercept is. I want to find the equation of the axis of symmetry and what the x-coordinate of the vertex is. So the first thing that we want to do, I'm going to go ahead and put this up here to the side. The first thing that we want to do is figure out what our a, b, and c are, right? So we've got these a, b, and c that we need to figure out. So if we take a look at our function here, we can say that if we just bring down, it's just the coefficient of in front of every one of our variables, right? So you've got, this one is going to be a 1, so a equals 1. B equals 4 because it's the coefficient, the number in front of the x term. And our c equals a negative 3. So the first thing that we wanted to find was our y-intercept, right? We wanted to find our y-intercept. So our y-intercept is where our x value is 0, right? So a times 0 plus b times 0 plus c, so c is our y-intercept. So if we look here, our c is negative 3. So our y-intercept can be found just by looking at this equation. So y-intercept is negative 3. Now, in order to find the next piece, which is the equation of the axis of symmetry, it says the equation to find that is x equals negative b over 2a. All right, so we're going to use our a and our b to find our axis of symmetry. So we're going to get, so we have, let's see, x equals negative b over 2a. All we need to do, we know what our a and b are, so we just need to plug them into the equation. We get x equals negative 4 is our b, 1 is our a, so we get negative 4 over 2, which negative 4 divided by 2 gives us a negative 2. So this equation right here is our axis of symmetry. So we've gotten our y-intercept, we have our equation of the axis of symmetry, and now we need the x-coordinate of our vertex. Okay, so I'm going to move this bad boy up here. And if we look, here is exactly what it is. The x-coordinate of our vertex is negative b over 2a, which if you recall, our axis of symmetry, which is right here, only hits our parabola at one point, at the vertex, right? So if this is our axis of symmetry, it makes sense that our equation has to go through our vertex. So we're going to get a vertex of negative 2. So we have a vertex that has an x value of negative 2. And now we're going to take these pieces of information and graph this function. So we're going to go to where x is 0 and y is negative 3 and plot a point. Alright, so that's where our y-intercept is. And we know that we have an axis of symmetry on x equals negative 2. So this always trips people up a little bit. The axis of symmetry is going to be a vertical line, and when you have x equals something, it's going to be a vertical line, because if you notice, this is our x-axis, correct? So if we find x equals negative 2, x equals negative 2 is right in here. So if I move down, is my x value still negative 2? Yes. If I continue to move down, my x value is still negative 2. My y value is changing, but that doesn't matter as long as my x equals negative 2. So anything along this line right here is x equals negative 2. So we're going to go ahead and draw our axis of symmetry. Okay, that's our axis of symmetry. And then we know that our vertex has to be along this line somewhere, but we don't know the y value yet. So we can't plot it yet. So we have our y-intercept here and our axis of symmetry. What's cool about this is that we can find one more point just from what we're given right here. So if this is our axis of symmetry, and we were to take anything that's on this side, fold it over this axis of symmetry, it should draw whatever should be over here, correct? So if we have this point, and I am 2 from my axis of symmetry, if I go 2 more, it's a reflection, this is another point that I can make. So I can make a point right here. But 2 points is not enough to draw the line for a parabola, because we don't know yet if it's opening up, we don't know if it's opening down, we don't know how skinny it is, we don't know any of that just yet. So we need to find some more points. So that's where a table is going to come in. So I drew a table out to the side, and I'm going to pick some points. I do want to know what the y value is for my vertex, so I'm going to go ahead and pick negative 2 as the first point that I'm going to plug in, so the first x value. So if I have negative 2 squared plus 4 times negative 2 minus 3. And when I plug that x value in, I get a negative 7. So this is the other part to my vertex, correct? My f of x is negative 7. So I'm going to find this. So we already know that this line is where x equals negative 2, and now I need my y value, or my f of x value, to be negative 7. So 1, 2, 3, 4, 5, 6, 7. So right here at the bottom, I'm going to make a point right here. Okay, now I have my vertex. So really 3 points is all that you need to draw your parabola. If more makes it more perfect, but 3 will do. So I want to connect these 3 points with a curved line. I don't want it to be straight. I want it to be curved. So and then the other side, not super symmetric, clearly, but it'll do. So that's kind of what our parabola is going to look like. Now I want you to answer this question for me. What is the domain and the range of this function? I'll be looking for this in your notes tomorrow. Some more of our vocabulary words are talking about maximums and minimums. So using this as an example, we have a parabola that is opening up, right? It's like a U. And so therefore we have a minimum in this case because we have a lowest value. If it was a parabola like this, we would have a maximum at the top, right? It's like a mountain or a ditch. Yep. So in this case we have a minimum. And our minimum is right here. It's our vertex, always. So when we're asking for maximum or minimum of a parabola, it is your vertex. So in this case, we have a minimum and when we're talking about minimums, we're talking about our y value because our y-axis is our vertical axis. So we have a minimum to our vertical axis. So our minimum in this case is going to be our y value, which is negative 7, which equals negative 7. So I realize I just threw a lot of vocabulary words at you, really, really quickly, but we're going to practice this. But just remember that some of the key concepts that we're talking about here is parabolas. We're graphing quadratic equations where we are finding our y-intercepts. We're finding our axis of symmetry, our vertex, okay? All of these are modeling parabolas. And remember that it's always helpful to make a table of values because if you don't know where to begin, it is imperative that you start with just by picking an x value that you want to start with or picking a y value. Y values are difficult, but you can pick an x value that you want to start with and find your y according to that. So this sums up for the basics of graphing quadratic functions, and we're going to practice this tomorrow, and we're about to get into what solving quadratic functions look like by graphing and by algebra.